Okay, so we're going to graph things in quadratic form, quadratic equations in vertex form. Um, Similar, just a few little differences than standard form. Okay, up top here, this is the basic idea of this is the formula for vertex form. So we're going to graph using a table. What's the vertex? The vertex is whatever the opposite of this number is. So it says x minus 1, that's negative 1. So make it positive 1, okay, because we're going to go to the right one. And whatever number that is, 3. So it looks like you would pick negative 1, but you actually pick positive 1 because it's going to go to the right. And I'll show you why in a little bit. Okay, what's the axis of symmetry? You remember from last week that the axis of symmetry is x equals whatever number that is. So that's x equals 1. Okay, so let's make a table and see how the graph looks. So our x goes on the left, y goes on the right. Now we're going to put our vertex in the middle of our table. We're going to put 2 numbers above, 2 numbers below. And we're going to plug these numbers into our calculator into this formula. So we're going to plug in 2 for x. 2 minus 1 is 1. Squared is 1 times 2. 2 plus 3 is 5. And that must mean that 0 makes 5 too, because these two have to be the same because of symmetry. Now I'm going to plug in 3. 3 minus 1 is 2. Squared is 4. Times 2 is 8. 8 plus 3 is 11. Which means that negative 1 must also be 11. So now that we got our values, now again, if you can't do that in your head, and I don't expect you to, plug these into the calculator the way you see it. Scientific calculator with the parentheses and everything. So now I'm going to graph my function. Actually, let me make my x-axis down here because I see all my y values are positive. So 1 comma negative 3. I go right 1 and up 3. That's this point right here. 0 comma 5. I go over 0 and up 5. So that's this point right here. 2 comma 5 is this point right here. 3 comma 11. So I got 6, 7, 8, 9, 10, 11. So 3 comma 11. And then negative 1 comma 11 is right here. So I connect my points and I have my U shape. And it should look more like a U than that does. I just have trouble with this pen here. So that's my parabola. My x equals 1. It cuts the graph in half. That's not what 1 is. 1 is here. It cuts the graph in half, and it should be the same on both sides. Unfortunately, my U's not looking so good, but you get the idea. Let's see. Now, what changed from x squared? So y equals x squared is down here. Okay, that's the parent function. So what happened? It moved right 1. Right, this point moves to the right 1. It went up 3 because of this 3. And that 2 made it a little bit skinnier. Okay? So that's called a transformation. X squared is the parent function. And then if you want to talk about domain and range, if you remember, I told you a little hint that the domain is always negative infinity to infinity for quadratics because it's never going to stop going left and right. Now the range does stop. It stops going down here. It stops at 3 and goes up. So it goes from 3 to infinity. That's the range. And of course, my vertex again is 1 comma 3, and my axis is x equals 1.